Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. A deep voyage through our solar system. Facts and curiosities. Prologue. The launch. In the heart of our solar system lies the Sun, a colossal fusion reactor that gives life and light to all its planetary children. Embark with me on a grand voyage through this celestial family, where each planet and moon holds unique mysteries and wonders. Buckle up as our spacecraft ignites, propelling us into the infinite expanse of space. Chapter 1. Mercury, the Scorched Messenger. Mercury, the innermost planet of our solar system, orbits closest to the Sun. Named after the Roman messenger god due to its swift orbit around the Sun, Mercury completes a revolution in just 88 Earth days. However, its day, the time it takes to rotate once on its axis, lasts about 59 Earth days. This peculiar rotation period, combined with its elliptical orbit, leads to extreme temperature fluctuations on its surface. Mercury's surface is a harsh, barren landscape, reminiscent of our moon. It is covered with craters from billions of years of asteroid impacts, including the massive Caloris Basin, which is about 1,550 kilometers, 960 miles, in diameter. The planet's composition is primarily metallic, with a large iron core making up about 85% of its radius. This core generates a weak magnetic field, only about 1% as strong as Earth's. The proximity to the Sun subjects Mercury to intense solar radiation. Daytime temperatures can soar to 430 degrees Celsius, 800 degrees Fahrenheit, hot enough to melt lead. Conversely, the lack of a significant atmosphere to retain heat causes nighttime temperatures to plummet to minus 180 degrees Celsius, minus 290 degrees Fahrenheit. This dramatic temperature difference, one of the most extreme in the solar system, highlights Mercury's tenuous exosphere, composed mainly of oxygen, sodium, hydrogen, helium, and potassium. Mercury's orbit is the most eccentric of all the planets, meaning its distance from the Sun varies significantly over the course of its orbit. At perihelion, closest approach, Mercury is about 46 million kilometers, 29 million miles, from the Sun, while at aphelion, farthest point, it is about 70 million kilometers, 43 million miles, away. This eccentric orbit, combined with its slow rotation, creates a peculiar phenomenon where the Sun appears to move in a strange, looping path in Mercury's sky. Despite its proximity to Earth, Mercury has been a challenging target for exploration due to the intense heat and gravitational pull of the Sun. NASA's Mariner 10 mission in the 1970s provided the first close-up images of Mercury, revealing its heavily cratered surface. More recently, the Messenger mission, which orbited Mercury from 2011 to 2015, mapped the planet in detail and discovered ice in permanently shadowed craters near its poles, a surprising find given Mercury's proximity to the Sun. Chapter 2. Venus, the Veiled Furnace. Next, we venture to Venus, the second planet from the Sun and often referred to as Earth's twin due to its similar size and rocky composition. However, the similarities end there. Venus is a world of extremes, with a thick, toxic atmosphere and surface conditions that are hellish compared to Earth's. Venus's atmosphere is composed primarily of carbon dioxide, with clouds of sulfuric acid, making it highly reflective and giving the planet a bright, yellowish-white appearance when viewed from Earth. The atmospheric pressure on Venus's surface is about 92 times that of Earth, equivalent to being nearly a kilometer, 3,280 feet, underwater. This immense pressure, combined with temperatures of about 465 degrees Celsius (869 degrees Fahrenheit), creates an inhospitable environment where even lead would melt. Venus experiences a runaway greenhouse effect, where heat from the sun is trapped by its thick atmosphere, leading to its scorching surface temperatures. This effect is exacerbated by the dense carbon dioxide in the atmosphere, which efficiently traps heat. Uniquely, Venus rotates in the opposite direction to most planets in the solar system, a phenomenon known as retrograde rotation. A day on Venus, one full rotation, lasts about 243 Earth days, which is longer than a Venusian year, one orbit around the Sun, which is 225 Earth days. This means that if you were on Venus, you would experience a single sunrise and sunset over an entire Venusian year. The surface of Venus is a volcanic landscape, with vast plains, towering mountains, and large volcanic structures called coronae. These features are shaped by intense volcanic activity, with some evidence suggesting that Venus might still have active volcanoes. The planet's surface is relatively young, geologically speaking, with estimates suggesting it is less than 500 million years old, indicating that it has been resurfaced by volcanic activity. Venus has been a target of exploration since the early days of space exploration. The Soviet Union's Venera program successfully landed several probes on Venus in the 1970s and 1980s, providing the first images and data from the surface. These missions revealed the harsh conditions and confirmed the presence of volcanic plains and highland regions. More recently, ESA's Venus Express and NASA's Magellan missions have mapped the planet's surface and studied its atmosphere in greater detail, offering insights into its climate and geological history. Chapter 3. Earth, the Blue Marble. Leaving the inferno of Venus, we arrive at our home, Earth. Earth is unique in our solar system, a vibrant oasis teeming with life. Its perfect balance of temperature, water, and atmosphere supports a complex web of ecosystems, making it the only known planet to harbor life. Earth's surface is a dynamic mosaic of land and water. Oceans cover about 71% of the planet's surface, regulating temperature and supporting a vast array of marine life. The remaining 29% consists of continents and islands, featuring diverse landscapes from mountains and deserts to forests and plains. The atmosphere, composed mainly of nitrogen, 78%, and oxygen, 21%. Plays a crucial role in maintaining life by providing breathable air and protecting the planet from harmful solar radiation through the ozone layer. The atmosphere also helps regulate Earth's climate, trapping heat through the greenhouse effect, which keeps the planet warm enough to support life. Earth is the only known planet with active plate tectonics, a process where the planet's lithosphere is divided into several large and small plates that float on the semi-fluid asthenosphere beneath. The movement of these plates shapes the planet's surface, creating mountains, earthquakes, and volcanic activity. This geological activity also plays a vital role in the carbon cycle, helping to regulate the planet's climate over geological timescales. Water is essential for life as we know it, and Earth has it in abundance. Liquid water exists in oceans, rivers, lakes, and groundwater, providing habitats for countless species. The presence of water in its three states, liquid, solid, ice, and gas, water vapor, creates a dynamic hydrological cycle that distributes heat and moisture around the planet, influencing weather and climate. Earth's biosphere, the global sum of all ecosystems, is a testament to the planet's ability to support life. From the deepest ocean trenches to the highest mountain peaks, life thrives in a myriad of forms, adapted to virtually every environment. Earth's moon, our closest celestial neighbor, plays a significant role in the planet's natural processes. It stabilizes Earth's axial tilt, which helps regulate the climate by reducing extreme variations. The moon's gravitational pull also causes tides, influencing marine ecosystems and coastal environments. Curiosity. The moon is slowly drifting away from Earth at a rate of about 3.8 centimeters, 1.5 inches, per year. This gradual separation affects the length of Earth's days and the stability of its axis over long periods. Human exploration of Earth's immediate environment began with the Apollo missions, which landed astronauts on the moon and returned samples for study. These missions provided unprecedented insights into the moon's composition and history, as well as the Earth-Moon system's dynamics. Earth observation satellites have revolutionized our understanding of the planet's climate, weather patterns, and environmental changes, providing critical data for managing natural resources and addressing global challenges such as climate change. Chapter 4. Mars, the Red Planet. Our next destination is Mars, the fourth planet from the Sun, often referred to as the Red Planet due to its reddish appearance. Mars has captivated human imagination for centuries, inspiring countless stories of alien life and exploration. Its surface, with its towering volcanoes, vast canyons, and dry riverbeds, tells a story of a planet that may have once been very different from the cold, arid world we see today. Mars is a rocky planet with a thin atmosphere, primarily composed of carbon dioxide. The surface is covered with iron oxide, or rust, giving it its distinctive red color. Mars's topography is varied and dramatic, featuring the tallest volcano in the solar system, Olympus Mons, and the largest canyon, Valles Marineris. Standing at about 22 kilometers, 13.6 miles, high, Olympus Mons is nearly 3 times the height of Mount Everest. Its base is around 600 kilometers, 373 miles, in diameter, roughly equivalent to the size of the state of Arizona. Stretching over 4,000 kilometers, 2,500 miles, long, 200 kilometers, 125 miles, wide, and up to 7 kilometers, 4.3 miles, deep. Valles Marineris is a canyon system that dwarfs Earth's Grand Canyon. Mars has a thin atmosphere with a surface pressure less than 1% of Earth's. This atmosphere is not thick enough to retain much heat, resulting in cold surface temperatures that average about -80 degrees Celsius (-112 degrees Fahrenheit), but can vary from -195 degrees Fahrenheit (-125 degrees Celsius) at the poles during winter to a comfortable 70 degrees Fahrenheit (20 degrees Celsius) at midday near the equator. Mars experiences seasons similar to Earth's due to its axial tilt, but they last about twice as long since a Martian year is 687 Earth days. The planet is also known for its planet-wide dust storms, which can last for weeks or even months, significantly affecting surface conditions and visibility. Evidence suggests that Mars once had liquid water flowing on its surface. Ancient river valleys, lake beds, and mineral deposits indicate that water was present for extended periods. Recent discoveries have found signs of liquid water in the form of briny flows during the warmer months, although the volume is minimal. The search for life on Mars focuses on finding microbial life forms that could have existed when the planet had a more hospitable climate. The discovery of methane in the Martian atmosphere, a potential biosignature, has fueled speculation about the possibility of life, past or present. Mars has 2 small, irregularly shaped moons, Phobos and Deimos. They are thought to be captured asteroids from the asteroid belt, and both have a significant impact on Mars's surface conditions. The larger of the 2 moons, Phobos, is gradually spiraling inward towards Mars and is expected to either crash into the planet or break apart and form a ring system within the next 50 million years. Smaller and farther from Mars, Deimos orbits more slowly and is less likely to collide with the planet. Mars has been a primary target for exploration due to its potential for past life and its similarities to early Earth. The Viking missions of the 1970s were the first to land on Mars and conduct experiments searching for signs of life. More recent missions, such as NASA's Mars rovers Spirit, Opportunity, Curiosity, and Perseverance, have provided detailed analyses of Martian geology and climate, discovering evidence of ancient water and more. The Mars Odyssey and Mars Reconnaissance Orbiter missions have mapped the planet's surface and subsurface, revealing water ice deposits and providing critical data for future human exploration. Chapter 5. The Asteroid Belt, a rocky highway. Between the orbits of Mars and Jupiter lies the asteroid belt, a vast region filled with rocky and metallic remnants from the early solar system. These objects range from tiny dust particles to dwarf planets like Ceres. The asteroid belt serves as a natural laboratory for studying the building blocks of planets and the conditions of the early solar system. The asteroid belt contains millions of objects, but the total mass of all the asteroids combined is less than that of Earth's moon. The objects in the asteroid belt are categorized into different types based on their composition. C-type, carbonaceous, asteroids. These are the most common, making up about 75% of known asteroids. They contain a large amount of carbon, along with water ice and organic compounds. S-type, silicaceous, asteroids. These make up about 17% of asteroids and are composed primarily of silicate minerals and nickel iron. M-type, metallic, asteroids. These are made mostly of metallic iron and nickel and are less common. The asteroid belt is not a densely packed region of space as often depicted in science fiction. The average distance between asteroids is about 1 million kilometers, 600,000 miles, so spacecraft can navigate through the belt with relative safety. The largest object in the asteroid belt is called Ceres, classified as a dwarf planet. It has a diameter of about 940 kilometers, 584 miles, and contains about a third of the mass of the entire asteroid belt. Ceres has a differentiated interior with a rocky core and an icy mantle. Its surface features include large craters, bright spots of salt deposits, and cryovolcanoes that may have once erupted with briny water. NASA's Dawn mission, which orbited Ceres from 2015 to 2018, provided detailed images and data, revealing its complex geology and signs of past and possibly present water activity. The asteroid belt is of great interest not only for scientific exploration but also for potential resource utilization. Asteroids contain valuable materials such as water, metals, and other resources that could be used for space missions or even returned to Earth. Several missions have studied asteroids up close, including NASA's Near Shoemaker, which orbited and landed on the asteroid Eros, and Japan's Hayabusa missions, which returned samples from asteroids Itokawa and Ryugu. Private companies and space agencies are investigating the feasibility of asteroid mining, which could provide essential materials for building infrastructure in space and supporting long-duration missions. Chapter 6. Jupiter, the giant of the solar system. Our next destination is Jupiter, the largest planet in the solar system. This gas giant is a behemoth of swirling storms and colorful bands, dominated by the Great Red Spot, a gigantic storm larger than Earth that has raged for centuries. Jupiter's immense gravity influences many of its moons and the asteroid belt, making it a central figure in the dynamics of the solar system. Jupiter's atmosphere is composed primarily of hydrogen, about 90%, and helium, about 10%, with trace amounts of other gases such as methane, ammonia, and water vapor. The planet's appearance is characterized by its colorful bands and zones, created by high-speed winds and varying cloud compositions. Jupiter's Great Red Spot is a massive, persistent storm located in Jupiter's southern hemisphere, It has been observed for at least 400 years and measures about 16,350 kilometers, 10,159 miles, in width, making it wider than Earth. The storm's reddish hue is still a topic of research, possibly due to chemical reactions occurring in its upper atmosphere. Jupiter's cloud layers are composed of ammonia ice, ammonium hydrosulfide, and water ice. These clouds form intricate patterns and turbulent features, including smaller storms and vortices. Jupiter's interior consists of a dense core of heavy elements, surrounded by a layer of metallic hydrogen, where hydrogen exists in a liquid metallic state due to extreme pressure. Above this layer is an extensive region of liquid hydrogen and helium. Jupiter has the most powerful magnetosphere in the solar system, extending up to 7 million kilometers, 4.3 million miles, towards the Sun and almost reaching Saturn's orbit on the opposite side. This magnetic field traps charged particles and creates intense radiation belts, posing challenges for spacecraft missions. Jupiter has at least 79 moons, with the 4 largest, known as the Galilean moons, discovered by Galileo Galilei in 1610. Each of these moons is a fascinating world in its own right. Io, the most volcanically active body in the solar system. Io's surface is covered with sulfur and sulfur dioxide, giving it a colorful appearance. Its intense volcanic activity is driven by tidal heating from Jupiter's gravitational pull. Europa. Europa's icy surface hides a global subsurface ocean, making it one of the prime candidates for the search for extraterrestrial life. The ice shell is thought to be several kilometers thick, with potential plumes of water vapor venting into space. Ganymede. Ganymede is the largest moon in the solar system, even bigger than Mercury. It has a differentiated interior with a metallic core, and its surface features a mix of older, heavily cratered regions and younger, grooved terrains. Callisto. Callisto, the most heavily cratered object in the solar system, has a relatively undifferentiated interior and a surface that has remained largely unchanged for billions of years. Chapter 7. Saturn, the jewel of the solar system. Continuing our journey, we arrive at Saturn, the 6th planet from the Sun and the 2nd largest in the solar system. Saturn is famous for its stunning ring system, a complex and beautiful structure that sets it apart from all other planets. Beyond its rings, Saturn boasts a fascinating array of moons and atmospheric phenomena. Saturn's rings are composed primarily of ice particles, with a smaller amount of rocky debris and dust. The rings extend up to 282,000 kilometers, 175,000 miles, from the planet but are remarkably thin, generally only about 10 meters, 30 feet, thick. Saturn's rings are divided into several distinct parts, labeled alphabetically in the order they were discovered: A, B, C, D, E, F, and G rings. The Cassini division is a prominent gap between the A and B rings. The particles in the rings range in size from tiny dust grains to boulders up to several meters across. Saturn's atmosphere is composed primarily of hydrogen, 96%, and helium, 3%, with traces of methane, ammonia, and other gases. The atmosphere features bands of clouds and powerful storms, including the Great White Spot, a periodic storm that appears roughly every 30 years. Similar to Jupiter, Saturn's interior consists of a core of heavy elements surrounded by layers of metallic hydrogen, liquid hydrogen, and helium. Saturn has a powerful magnetic field, though not as strong as Jupiter's. This magnetosphere interacts with the solar wind and contributes to auroras near the planet's poles. Saturn has at least 82 moons, with Titan being the largest and one of the most intriguing objects in the solar system. Titan is the second largest moon in the solar system and the only one with a thick atmosphere. Its atmosphere is primarily nitrogen, with methane and other hydrocarbons. Titan's surface features lakes and rivers of liquid methane and ethane, and possibly an underground ocean of water mixed with ammonia. The Huygens probe, part of the Cassini mission, landed on Titan in 2005, providing detailed images and data. Another of Saturn's moons, Enceladus, has a subsurface ocean beneath its icy crust. Geysers at the south pole of Enceladus eject water vapor and ice particles into space, indicating hydrothermal activity on the ocean floor. This makes Enceladus another prime candidate in the search for extraterrestrial life. Other notable moons include Rhea, which might have a thin atmosphere, Dione, which has a subsurface ocean, and Iapetus, known for its stark contrast between its bright and dark hemispheres. Saturn and its moons have been studied extensively by the Cassini-Huygens mission, which orbited Saturn from 2004 to 2017. Cassini provided detailed data on the planet's rings, atmosphere, and magnetosphere, as well as close-up views of its moons. The mission's discoveries, particularly on Titan and Enceladus, have significantly advanced our understanding of the Saturnian system. Chapter 8. Uranus, the ice giant. Next, we venture to Uranus, the seventh planet from the Sun and the first to be discovered with a telescope, by William Herschel in 1781. Uranus is an ice giant, characterized by its pale blue color, due to the methane in its atmosphere, and its unusual axial tilt, which causes it to rotate on its side. Uranus's atmosphere is composed primarily of hydrogen and helium, with a higher proportion of ices such as water, ammonia, and methane. The methane absorbs red light, giving the planet its blue-green hue. Uranus has an axial tilt of about 98 degrees, meaning it rotates almost perpendicular to the plane of the solar system. This extreme tilt results in unusual seasonal variations, with each pole getting around 42 years of continuous sunlight, followed by 42 years of darkness. Uranus is one of the coldest planets in the solar system, with temperatures dropping to -224 degrees Celsius -371 degrees Fahrenheit. Despite its frigid temperatures, Uranus has dynamic weather systems, including massive storms and strong winds. The interior of Uranus is believed to consist of 3 layers: a rocky core, an icy mantle, and an outer gaseous hydrogen-helium envelope. The ice mantle contains water, ammonia, and methane, under high pressure and temperature conditions. Uranus has 27 known moons and a faint ring system. The moons are named after characters from the works of William Shakespeare and Alexander Pope. The largest moons, Titania and Oberon, are composed of roughly equal parts ice and rock. Both moons show signs of geological activity, including fault lines and possible cryovolcanism. One of Uranus's most unusual moons, Miranda, has a highly varied surface with canyons, terraces, and fault scarps, suggesting a history of significant geological upheaval. Uranus's rings are dark and faint compared to Saturn's. The rings were discovered in 1977 during a stellar occultation when the planet passed in front of a star, causing its light to dim. Uranus has only been visited by one spacecraft, Voyager 2, which flew by the planet in 1986. Voyager 2 provided the first close-up images and data, revealing details about Uranus's atmosphere, rings, and moons. Despite the limited exploration, Uranus remains a subject of interest for future missions, especially to study its unique tilt and composition. Chapter 9. Neptune, the windy blue giant. Our journey takes us to Neptune, the 8th and farthest known planet from the Sun. Neptune is similar in composition to Uranus and is also classified as an ice giant. Its deep blue color, caused by methane in its atmosphere, and its dynamic weather systems, including the fastest winds in the solar system, make Neptune a fascinating world. Neptune's atmosphere is composed mainly of hydrogen, helium, and methane. The methane absorbs red light, giving the planet its striking blue color. Neptune's atmosphere features large storm systems, including the Great Dark Spot, similar to Jupiter's Great Red Spot. This storm, discovered by Voyager 2 in 1989, was a massive anticyclonic storm that has since disappeared, but similar spots have appeared. Neptune has the fastest winds in the solar system, reaching speeds of up to 2,100 kilometers per hour, 1,300 miles per hour. These winds drive large storm systems and cloud formations across the planet. Neptune's interior structure is similar to that of Uranus, with a rocky core, an icy mantle, and a gaseous outer layer. The planet also has a powerful magnetic field, which is tilted relative to its rotation axis and offset from the planet's center, creating complex magnetospheric dynamics. Neptune has 14 known moons and a faint ring system. The most notable moon is Triton, which is unique among large moons for its retrograde orbit, meaning it orbits Neptune in the opposite direction of the planet's rotation. Triton is one of the coldest objects in the solar system, with surface temperatures around -235 degrees Celsius -391 degrees Fahrenheit. It has a thin atmosphere composed mainly of nitrogen, with traces of methane. Triton's surface features include geysers that erupt with nitrogen gas and a complex terrain with ridges, valleys, and frozen lakes. Neptune's rings are dark and faint, composed of dust particles and small rocks. The rings are named after astronomers who contributed to the study of the planet: Gall, Leverrier, Lassell, Arago, and Adams. Like Uranus, Neptune has only been visited by Voyager 2, which flew by the planet in 1989. The spacecraft provided the first close-up images and data on Neptune's atmosphere, rings, and moons, including Triton. Future missions to Neptune are of great interest to scientists, especially to study its dynamic atmosphere and the unique characteristics of Triton. Chapter 10. Pluto and the Kuiper Belt, the frontier of the solar system. Our final stop takes us beyond Neptune to Pluto, once considered the ninth planet, now classified as a dwarf planet. Pluto resides in the Kuiper Belt, a region of the solar system filled with icy bodies and remnants from its formation. Pluto's surface is a mix of nitrogen, methane, and carbon monoxide ices, with mountains made of water ice. The dwarf planet has a complex and varied surface, featuring plains, mountains, and possible cryovolcanoes. One of the most prominent features on Pluto is the Sputnik Planitia, a large, heart-shaped plain made of nitrogen and methane ices. This region is geologically active, with evidence of convection and glacial flow. Pluto has a thin atmosphere composed mainly of nitrogen, with traces of methane and carbon monoxide. The atmosphere undergoes seasonal changes, expanding and contracting as Pluto moves closer to and farther from the Sun in its elliptical orbit. Pluto has 5 known moons, with Charon being the largest and most significant. The other 4 moons are Styx, Nix, Kerberos, and Hydra. Charon is almost half the size of Pluto, making it one of the largest moon-to-planet size ratios in the solar system. The gravitational interaction between Pluto and Charon is so significant that they orbit a common center of mass outside of Pluto, making them a binary system. Charon's surface is covered with water ice and shows signs of geological activity, including a large canyon that stretches across the moon's surface. Nix and Hydra are smaller and have irregular shapes. They are composed of water ice and have highly reflective surfaces, suggesting a relatively young age. They were discovered by the Hubble Space Telescope in 2005. Styx and Kerberos are the smallest and dimmest of Pluto's moons, discovered in 2011 and 2012, respectively. Their orbits are influenced by the gravitational pull of both Pluto and Charon, creating complex interactions within the system. Beyond Pluto lies the Kuiper Belt, a vast region filled with icy bodies and dwarf planets. It extends from about 30 to 55 astronomical units (AU) from the Sun and is similar to the asteroid belt but much larger and more massive. The Kuiper Belt contains thousands of small icy objects, known as Kuiper Belt objects, KBOs, composed of frozen volatiles like methane, ammonia, and water. Notable KBOs include Eris, Haumea, and Makemake, all of which are classified as dwarf planets. Eris is slightly smaller than Pluto but more massive, and its discovery in 2005 led to the redefinition of what constitutes a planet. Pluto and the Kuiper Belt were explored up close for the first time by NASA's New Horizons mission. Launched in 2006, New Horizons performed a historic flyby of Pluto in July 2015, providing unprecedented images and data about Pluto, its moons, and its atmosphere. The mission revealed Pluto's diverse surface features, including mountains, plains, and potential cryovolcanoes. It also captured detailed images of Charon and the smaller moons, shedding light on their compositions and histories. After its flyby of Pluto, New Horizons continued into the Kuiper Belt and encountered the KBO Arrokoth, formerly known as Ultima Thule, in January 2019. This encounter provided insights into the formation and characteristics of Kuiper Belt objects. Conclusion: the journey home. As our voyage through the solar system comes to an end, we reflect on the incredible diversity and complexity of the planets, moons, and other celestial bodies we have encountered. From the rocky terrains of the inner planets to the gas giants and icy worlds of the outer solar system, each destination has offered unique insights into the processes that shape our cosmic neighborhood. Exploring the solar system is not just about satisfying human curiosity. It provides critical knowledge that helps us understand the history and evolution of our own planet. Each mission, each discovery, adds a piece to the puzzle of our existence and the conditions that led to life on Earth. The journey through the solar system is far from over. Future missions are planned to explore the icy moons of Jupiter and Saturn, the surface of Mars in greater detail, and the distant reaches of the Kuiper Belt. Human exploration is also on the horizon, with plans to return to the Moon and eventually send astronauts to Mars. Perseverance rover is currently exploring Mars, searching for signs of past life and collecting samples for future return to Earth. The European Space Agency's ExoMars mission aims to drill beneath the surface to search for biomarkers. NASA's Europa Clipper mission, expected to launch in October 2024, will conduct detailed reconnaissance of Jupiter's moon Europa, investigating its potential habitability and searching for signs of life in its subsurface ocean. NASA's Artemis program aims to return humans to the Moon by the mid-2020s, establishing a sustainable presence and preparing for future missions to Mars. Our voyage through the solar system has highlighted the intricate and interconnected nature of the celestial bodies that share our Sun. From the fiery core of our star to the icy reaches of the Kuiper Belt, each element plays a role in the grand tapestry of the cosmos. As we continue to explore, we gain not only knowledge about the universe but also a deeper understanding of our place within it. We are part of a vast, dynamic system that has evolved over billions of years, and our curiosity drives us to uncover the secrets that lie beyond the horizon. In the words of Carl Sagan, exploration is in our nature. We began as wanderers, and we are wanderers still. We have lingered long enough on the shores of the cosmic ocean. we are ready at last to set sail for the stars. Our journey through the solar system is just the beginning of humanity's quest to understand the universe and our place within it.